Now, we're going over a chi-squared test, problem 24 of chapter 14, and we're given a contingency table that displays the origin of manufacture of different vehicles, Asia, Europe, and the US, and whether or not the car suffers some sort of mechanical problem, which is displayed by yes, it does a mechanical problem, or no, it does not. And the first part is to state your hypothesis. And to do so, we're given expected values in comparison to the sample right here. And the null hypothesis would be that the reliability of a vehicle is independent from its country of origin. While the alternate hypothesis is that the reliability of a vehicle is dependent on its country of origin. However, state and check conditions, the counted data there accounts for the categories both of origin of manufacturer and for whether or not it suffers a problem, and totals and different subcounts here. Random yes, it's from Consumer Reports, a very widespread household magazine, a huge customer base to draw different samples from. And expected cell frequency, all the expected values are greater than 5. Now I find the amount of degrees of freedom that there are, which is row minus 1 times the value of the columns minus 1. Now there are, see, 3 categories here, 2 categories here, so then 3 minus 1, then 2 minus 1, and then you get a total of 2 degrees of freedom. Now the calculation yields that the chi-squared value is 2.928, and the p-value is 0.231. Now you can see those same values reflected here under the Pearson test. And what that means is because this value is above 0.05, you retain the null hypothesis. And you fail to reject that the relationship between the manufacturing country of origin is independent. So basically all the evidence points toward more evidence points towards the null being true instead of the alternative. And would you expect a larger sample might find more statistical significance? Yes, because a larger sample size is more likely to find the true proportion, because a larger sample size is less affected by outliers and is closer to a normal distribution.